Oh, yesterday we took a look at how to solve a quadratic equation by factoring. Previously, we looked at how to solve a quadratic equation by graphing. Today, we're going to take a look at some examples that you might encounter of where you could use those skills. So if you read the question, this comes from your textbook, and it's a continuation of the notes from yesterday. So they give us a function. We know it's a function because it's equal to a variable. And we know with any function, we're going to want to visualize this. So I'm going to just make a little sketch here of what's going on. And so we know this is vertex form. So if you think back to when we looked at quadratic functions, we know our vertex is going to be 5 and 25,000. So I'm just going to kind of go over here, 5, 25,000. I'm going to put my vertex there. We also know from quadratic functions it's opening down because my a value is negative. So again, I'm just going to do a rough sketch of my parabola. It's going to go something like that. Now, if you keep reading this question, it says, what should the price of the ticket be if we want to collect a revenue of $21,000? This is the revenue, and if we go back into our function, we can see that revenue is in the place of the y. So I'm going to add that to the sketch. I'm going to put down this is the revenue, and x in this particular case is the number of 10 cent price increases. So I kind of have an idea of what the graph looks like. Now, I'm going to turn this function into an equation by taking the revenue that we want to generate and substituting it in for the revenue here. So I'm going to put in here 21,000 on the left-hand side, and that's going to equal negative 40, and then x minus 5 squared plus 25,000. Now, this particular question does not specify that we have to solve it algebraically. So one strategy is we could just graph this as y1, and that's going to put a line, horizontal line, across here at 21,000. You're going to have to change your window so that your y-axis is, your y maximum is higher than 21,000. And then you would look for what is the x-coordinate at those points of intersection. You would graph the second side here as y2 and then generate those points of intersection. So that's one method. And then I can show you how to go about finishing that question. But I am going to do this algebraically, just because oftentimes the question will specify that they do want you to do this algebraically. So remember, if we're going to factor something, which is the only strategy we have at this point, we need it to be in standard form. So the first thing we're going to do is turn this into standard form. So I'm going to leave my 21,000 on the left. And similar to what we did with quadratic functions, the first thing we need to do is get rid of the brackets. We're going to FOIL out our binomial. Square the first term, double the product. 5 squared, negative 5 squared is 25. Square the last term, and that gives us that. And then the next thing I'm going to do is distribute that negative 40 into the bracket. So I'm going to leave my 21,000 here. We're going to have negative 40 x squared. Negative 40 times negative 10 becomes positive 400x. And negative 40 times 25 becomes negative 1,000. And we still have that 25,000. Okay, so now I'm going to combine my like terms, and I'm going to actually subtract that 21,000. And we have two constants here, so we could combine them, but I'm just going to subtract that first of all. So 25,000 minus 21,000 gives us 4,000. 4,000 plus negative 1,000 gives us 3,000. So we have 0 on the left, and remember that 0 is important. That's what makes it an equation that's solvable. And then these are just going to carry on. Combine those two terms together, and we have plus 3,000. We now have a quadratic equation in standard form. First thing we do when we factor is check for a greatest common factor. And I'll give you a hint. Oftentimes, if the numbers are really large, check to see if this leading coefficient, a, divides evenly into the other terms. Oftentimes it will, making the numbers a lot more manageable. So I'm going to divide out that negative 40 from all three terms. And then again, you can go 400 divided by negative 40 is going to give us negative 10x. 3,000 divided by negative 40 is going to give us negative 75. And then similar to what we did in the past, we're going to say, okay, this is a trinomial. Multiply a and c, what multiplies to give us negative 75 and adds to give us negative 10. And when we do that, we see that the numbers are negative 15 and positive 5. And again, if you can't quickly see that, make a list of your factors. So I'm going to set up my binomials, and then we're going to say what are the first terms we need to multiply to get back to x squared. And so it's going to be x times x. These, remember, are the products of the outside and inside terms. So we're going to say 1 times what gives us one of those numbers, and because it's a 1, we can choose either of them. So I'm going to put in a negative 15, and then the inside, we're going to say 1 times what gives us the other number, and it's going to be a positive 5. And then quickly just FOIL that out to make sure you get back to what we should get. And then the last thing we're going to do is solve for x. So we can see if we set each of these factors equal to 0, we're going to say what does x have to be that would make this 0? Negative 5. What does x have to be that would make this 0? Positive 15. So I know that x is negative 5 and positive 15. Okay, so those are my x-intercepts. So I know that this is actually crossing the x-axis at negative 5, and this is crossing the x-axis at 15. I labeled negative 5 and 15 on my x-axis, and then I also went back to the question and said, x is the number of 10% price increases. So then I just filled this in. So this represents the number of 10% price increases. So basically, we're going to collect a revenue of $21,000 if we have 15 price increases, each of 10 cents, or if we have negative 5 increases of 10 cents each. So basically, negative 5 is going to be a decrease of 5 times 10 cents, which is 50 cents. So we ultimately are trying to figure out what should the price ticket be. And we know up here we start at $2 a ticket. So to conclude this, we're going to take that $2 ticket and we're going to say, okay, the ticket is originally $2. If we have 5 decreases of 10 cents, so we have $2 minus 50 cents gives us a ticket price of $1.50. We also know that we hit a revenue of $21,000 if x is equal to 15, which means we have 15 10-cent price increases. So then start with the original ticket price of $2. We're going to add 15 increases, each of 10 cents. So 15 times 10 cents is $1.50. $2 plus $1.50 is $3.50. So to collect a revenue of $21,000, the ticket price could be $1.50, and it could also be $3.50. All right, you're going to try a couple of questions today, and we're not going to do very many because I want you to do them really well. So we're going to take our time. And on page 411, I want you to try 13 and 14. 13, I would like you to try algebraically just to get some factoring practice. And then 14, you can choose to do it graphically if you wish. I'm going to give you a hint. When you set up number 13, we always start with a sketch. Label the axes. What do we know? So this is the function that they give you. In place of the y, we have p of n. So p, they tell you in the question, represents profit. And you need to watch the units. In this case, profit is in thousands of dollars. So if you have a profit of 10, that means 10,000. If you have a profit of 3, that means 3,000. And then similarly, n represents the number of posters sold each month in hundreds. So if you get a 2, that means 200 posters sold. If you get a 7, that means 700 posters sold. And then another hint is, because I want you to try this by factoring, if you have a number for a, so we always check for a greatest common factor first, especially if you have a number like this, a decimal, a negative, try to divide it out of all of the terms. So check, does negative 0.25 divide evenly into all three of those terms? And it does in this case. So we can take this out as the greatest common factor, and then the trinomial that we're left with has numbers that are a lot more manageable to work with. Now we can multiply a and c and say, okay, what multiplies to 108, what adds to negative 24, and get those two values. If you're not quite sure, make a list on the side of your factors and then go from there. And then you're going to factor this. Because this is a 1n squared now, we're just going to go n times n to get back to that value. And then you're going to say n times what gives us one of those numbers, n times what gives us the other number. And then once you have the value of n, just remember, n is in hundreds of posters. So multiply by 100 to get your solution. B, similarly, gives you a profit of $5,000. But remember, profit is in thousands of dollars. So when we put this into the function, and it's going to turn it to an equation, we're going to just simply put the 5. And it does tell you that in the question. And then from there, remember from yesterday, we always want to turn it into standard form before we can actually factor. So I'm going to get 0 on one side. It's really important you write that 0 there. And then similar to the last one, see if you can divide out that negative 0.25 to get numbers that are nicer to factor in the trinomial. So I'm going to get you to try 13, set it up, see what you can do with that one. And then 14, you want to draw a sketch, you want to label your axes, figure out what it is you're looking for. Try to do it by factoring, see if you can do it. If you can't, try it by graphing and see what you can get that way. So not very many today, but we want to do a good job of making sure we set them up properly, making sure we understand them, and then that will conclude solving a quadratic equation by factoring. Tomorrow we'll move on to the quadratic formula. All right, have fun with those, and I'll see you tomorrow. Bye.